Now we're going to start with this lesson on linear functions and focusing very much on what is a linear function and how can we recognize a linear function. So we're going to take a look through the notes and try to detail certain pieces of a linear function. So a linear function, what is it? A linear function is a pattern. And in very specifically, it is a pattern which compares two ascending or descending values. Okay, so it's going to be what we've seen in the past, and we'll see some examples here as well of patterns that are linear functions. They go up or down by a steady value. Okay, so the difference that they're going up and down by is part of that pattern. Now, as one value is changing, the other follows according to the pattern. Each first value will have a matching second value, and these pairs of values are unique to that pattern. These sets of values can be shown using a chart or a graph, and we can also use an equation can also be used to calculate the pairs. Okay, depending on how far we want to go up, we can use an equation to calculate the pairs. So if we take a look at this example here, we have the pattern 1, 2, 3, 4, 5. This is the first, second, third, fourth, and fifth value in the pattern. It happens that the first value is 1, second is 2, third is 3. So if I were to ask you what the 10th value would be, well, we would say 10. The 100th value would be 100. This one's a little more difficult, 2, 4, 6, 8, 10. Okay, again, a little bit more difficult, not overly, but a little more difficult. Okay, what is the 10th value? Well, that would be 20 because we're going up by 2s. Okay, it's something that we can kind of use, and we can use a equation to calculate that. Okay, as I said, this is done, or as we're going to go through, this is done using variables to represent the two values. Okay, so we're going to take a look at a couple of these patterns here. Okay, so here's one, 1, 2, 3, 4, 5. Okay, can we come up with the next ones, right? Well, we know this is 6, 7, 8. We're going up by 1 each time. Okay, if we take a look at the next one, 2, 4, 6, 8, 10, we have 12, 14, 16. Whoop. And we're going up by 2s. And then the last one here, we have 10, 7, 4, 1, negative 2. This one's maybe a little more on the tricky side. We have negative 5, negative 8, negative 11. We are going down by 3. Okay, these are patterns. We've been looking at patterns for years and years already, and we should be able to kind of understand what a pattern is doing. Okay, so we can probably guess those next 3, and again, we're going to assume these patterns are continuing along in that normal stretch. Okay, so that's what those patterns are going to have here. Now, each of these patterns that we see here, okay, each of these 3 patterns are linear. As they increase or decrease by the same value each time. Okay, so we're going up by 1, up by 2, down by 3. We could see patterns that have any sort of different kind of going up or down by, but it's always going to go up or down by the exact same value. Okay, the exact same value. Now, there's another way that we can describe these patterns. Sorry, not describe, but another way that we can chart these patterns or display these patterns is by putting into a table of values. And now you'll notice we have 2 different pieces here. What we're going to have is we're going to have the value of the pattern. So 1, 2, 3, 4, 5. And then I'm going to give this a title here. This is the figure number, or we could even call it the placement. If you want to call it that, one or the other. Okay. In this first one here, this is the first, second, third, fourth, fifth. 1, 2, 3, 4, 5. So the first one is 1, second one is 2, third one is 3, fourth one is 4, fifth one is 5. If we do that with the next one, okay, again, I'll call it figure number again. and then the value. Okay, again, figure number is 1, 2, 3, 4, 5. Okay, but now our values are 2, 4, 6, 8, 10. And the goal is going to be, can we compare the figure number to the value? And can we determine what figure number gives us a certain value and what value gives us a certain figure number? Okay, that would be kind of part of the process that we would want to go through and want to be able to solve for. The last one, figure number and value. Again, 1, 2, 3, 4, 5, because these are the first 5 values in our pattern that continues and goes. And we would have 10, 7, 4, 1, -2. Now, when we see these patterns here, we're always starting with number 1, right? 1, 2, 3, 4, 5, and then our values are in different forms. But we could actually go past, okay? So we could do figure 6, 7, 8, which we did up here. Or we could even go earlier and try to extrapolate as to what are going to be the next or the previous values. What was figure 0? What was figure -1? Figure -2? We could totally do that if we wanted to. Okay, that would be something that we could, in fact, do with a linear function. And we're going to be using our kind of equations and patterns and charts to be able to do that a little bit later on. Now, the left hand of the side of the table of values, we're going to call the figure number, as we mentioned, okay, in these cases. And the right-hand side is the value in the pattern. Okay, so it's kind of the placement of the pattern. So this is a place 1, 2, 3, 4, 5. This is the value 2, 4, 6, 8, 10. That's a little bit of what we're looking at. Again, we're seeing this kind of chart that is being formed. Now, like I said, to determine if a pattern is linear, okay, both the left and right sides must increase or decrease by consistent amounts. Now, they've got to increase or decrease by consistent amounts. We would consider this is going up by 1, up by 2, and these are going down by 3, right? The figure number is always going up by 1, okay? So that's pretty straightforward. But on this side here, we're trying to figure out what they're going up or down by. We could also say that this is going up by a -3, just represents it as going down 3. So we could use the terms +1, +2, or -3 would be the differences that we have. So let's take a look at these patterns and which of these 3 patterns is linear and which is not. Well, what we need to do is we need to take a look at both sides. So on the x side, we're going up by 2, 2, 2, 2. So we're going up 2, adding 2, adding 2. Here we are subtracting 3, subtracting 3, subtracting 3, subtracting 3. Is it always going up and down by a consistent amount? Yes. This one is linear. Okay, it is in fact linear. Now the next one, okay, we go down 6, down 6, down 6, down 6. So I'm just subtracting 6. And then here we're going up 5, up 6, up 7, up 8. In this case here, the left-hand side is going down by the same amount every time, but the right-hand side is not. It's going up by differing amounts, okay? This one is not linear. And the final one is a little bit of a tricky one. Here we're going up 1, up 2, up 1, and up 3. Okay. Right now, it kind of looks like it's not going up by the same values. This is going up 2, up 4, up 2, up 6. But in fact, this one is linear. If we were to go back and look at, so we have 1, 2, at 3, the third value would be 7. Okay, it fits right between 5 and 9. The 6th value would be 13. The 7th value would be 15. It in fact could follow a linear function because, a linear pattern, because we have a common value going up. When we go up by 1s, it would be. It's a little bit of a messed up one. I won't give you a whole lot of these, but that is a possibility that could represent a linear function as well.